there's one little issue with trig functions. Issues that they only work on right triangles. Yeah, that's kind of disappointing, right? You get this cool tool that you're like, oh, I can solve all the triangles with it. And then you figure out that, oh, this only works on right triangles, which is like a very small subset of all the triangles that you can draw. But have no fear. There is a thing called the law of cosines, where we can we can figure out a way to use trig functions to solve triangles in general. So suppose you have a triangle that looks like this. Suppose that you know that this side is like 5, this side is 10, and this side is 7. And you want to find an angle x here. So what you don't want to do is you don't want to say that like sine of x equals 5 over 10. That's not what you want to do. Because sine of x equals 5 over 10, that only works if you've got a right triangle with 5 and 10 and this being x. But this isn't a right triangle, and we can tell that off the bat because 5 squared plus 7 squared, is that equal to 10 squared? Does that satisfy the Pythagorean theorem? Well, 25 plus 49, is that equal to 100? Definitely not. So yeah, this isn't a right triangle, so don't do that. What we do instead is we use the law of cosines. And what the law of cosines says is it's kind of like the Pythagorean theorem. You start out with by labeling your sides. So if we've got, like, say this is we'll say this is A, B, C. This is angle C. You say the side C squared is equal to A squared plus B squared. That's the Pythagorean theorem, but then you minus 2AB cosine of angle C. So that is there, and this C angle is there. So it's really similar to Pythagorean theorem, but you're subtracting off a little bit to account for it not being a right triangle. So let's do that here. So C squared, C is 5. 5 squared equals A squared is, so 10 squared plus 7 squared minus 2 times 10 times 7 cosine of x. Let's box this so we don't run into it. Alright, so 25 equals 100 plus 49 minus 140 cos x. And then 25 equals 149 minus 140 cos x. So 140 cos x is equal to 124. Cos x equals 124 out of 140. Then we use our inverse trig. So x equals arc cos of 124 out of 140. And let's plug that in. Let's see what it is. Arc cos of 124 out of 140 in degrees. That is 27.66 degrees. So x equals 27.66 degrees. So that's how you find an angle of something that's not at a right triangle. Now, if you wanted to find a side, say that we didn't know what this was. Say this was, we didn't know what that was, but say we knew that the angle was 27.66 degrees. Well, now let's say this is y, this side is y. So what we would change in our equation here is this would become y, and that would become a known variable. So that's cos 27.66, and that'd be y squared. So if we were to solve this, let's get rid of that. Let's get rid of that. Oh, this also becomes a y. If we were to solve this, well, we'd end up with a quadratic equation that we'd have to solve for y, and we would just want to take the positive answer. Let's not go through the trouble of actually solving this by hand, but let's just type it in and get the answers that way. So 5 squared equals 10 squared plus y squared minus 2 times 10 times y cos of 27.66 degrees. And the solutions, there we go. There's our solution of y. It's approximately, so what they really mean is y is 7 here. And that matches up because that's what we had at first. So that's how you would find a side of a non-right triangle. So when in doubt, always use the law of cosines. Even if you accidentally use it on a right triangle, that's okay, because in the case of a right triangle, if this is A, B, C, and this is a right triangle, C squared equals A squared plus B squared minus 2AB cos, now this is 90 degrees. Well, cosine of 90 degrees, let's write that in. Cos of 90 degrees is 0. Well, it makes remembering values of trig functions a lot easier. But cos of 90 degrees is 0, so this is just c squared equals a squared plus b squared minus 2ab times 0. So this whole thing is 0, so we just get c squared equals a squared plus b squared, and we're right back to the Pythagorean theorem. So yes, when in doubt, law of cosines.